Okay, class, continuing our lectures on a Z transform. So I'm going to give you the second example for the Z transform, given that your signal is x of n, and the equivalent signal of the x of n is a of n, u of n. So given the basic equation for Z transform, which is x of z is equal to summation of x of n z raised to negative n when n is equal to 0 to positive infinity. So your x of n is a of n times u of n. So your x of z is equal to summation when n is equal to 0 to positive infinity. Your x of n, which is a n, u n, multiplied by z raised to negative n. So since this is a right side transform, so we know that your u of n is equal to 1 when n is 0 to positive infinity. So your x of z is the summation from n is equal to 0 to positive infinity, a raised to n, z raised to negative n. To make it to the form of infinite geometric series, we want to factor out the power n, which is equal to summation from n is equal to 0 to positive infinity, a multiplied by z negative 1 raised to n. So since now you're in the factor or in the form of infinite geometric series, we can identify your first term, which is for your case this is 1, and your common term, which is for your case this is a z negative 1. So substitute using the equation for infinite geometric series. Your x of z is equal to first term minus over 1 minus your common term, which is a z negative 1. So I want this to be on the positive power, so multiply by z. So you're given your x of z is z over z minus a. So given that your region of convergence, we know that your region of convergence is z absolute value greater than a, since this is a right side transform. So how do you draw your region of convergence? So this is your frequency plot. So this is a, this is 0. So draw a circle here. Your region of convergence is outside or greater than a. So note that on some books they call it outside the a. So normally it's outside when you're dealing with the right side transform, and when you're dealing with the left side transform, it's automatically on the inside of the circle. Later on our subject or on our discussions, I'm going to be showing you examples of a left side transform versus a right side transform. But for this case, our example is mostly focused on the right side transform. Okay, so given this, given this the signal, you were able to get the z transform of a n of u of n multiplied by u of n, which is equivalent to z over z minus a. So last example for this topic, and then I'm going to give you some exercises that you can answer by yourself. So example is x of n is equal to 10 u of n. So writing on the generic equation for x of z, or the z transform, summation of n is equal to 0 to infinity a x of n z negative n. So for your case, the z transform is summation of n is equal to 0 to positive infinity. What is your x of n, which is 10 u of n times z negative n. Note that this one is equal to z1 since your n is equal to 0 to positive infinity. Plus, you can factor out the n since you're dealing with the summation. So you're dealing with 10 summation of n is equal to 0 to infinity z to the negative n. So your first term is 1. Your common term is equal to z negative 1. Okay, so if that's the case, then your x of z is equal to common first term over 1 minus common term z negative 1 times the factor 10 here. So for your case, it's equal to 10 over 1 minus z negative 1. And for your case, you have to multiply it by z to make the powers on the positive exponential. So 10z over 1z minus 1. So what's your region of convergence? Your region of convergence, this is your z transform. Your region of convergence, since it's your right side transform, your absolute value of z is greater than 1. So if I'm gonna plot it, 1, then this is your ROC. Any questions?